You think you know the universe. You look up at the stars, you glance at the night sky, you measure distances with your eyes or your telescope, and you feel like you understand it. But you don't. Not really. Because everything you think you see, the sky above, the stars out there, even the light that reaches your eyes, is filtered through your senses and your brain. And those filters, as brilliant as they are fundamentally limited. They tell you the universe is one way, when in reality it's another, much stranger, much more unintuitive, and much more fascinating. Let's start with something simple. You look at a star, you see it twinkling in the sky, and you might think, that's the star, right there, now. Wrong. What you see is the star as it was years, decades, or even millions of years ago. Light doesn't travel instantaneously. It has a speed limit, the speed of light, 299,792 kilometers per second. Even at that mind-boggling speed, it takes time to get here. So the universe you're observing is not the universe as it exists now. It's the universe as it was. And this applies to everything. Every point in space is a window into the past. The night sky is a museum of cosmic history. That star that looks close might be 4 light years away. The light you see left it before you were born. That galaxy, faint and smudged, could be billions of light years away. The photons reaching your eyes traveled across unimaginable distances, carrying information that is ancient, and yet you interpret it as here, now. Our perception tricks us. Our brain creates a sense of immediacy where there is none. But there's more. You might think space itself is empty, a vast void between stars and galaxies. Wrong again. Empty space is not empty. It's a seething, restless, almost living thing. Quantum mechanics teaches us that the vacuum is filled with energy, with particles popping in and out of existence. In one sense, nothing is truly still. Every cubic centimeter of space is buzzing with activity invisible to the naked eye. The universe, even where it seems nothing is happening, is vibrant, dynamic, unpredictable. It's the opposite of a calm, empty void. And here's where intuition fails spectacularly. Gravity. You know gravity, right? Objects fall, apples drop, planets orbit. Simple. But what if I told you gravity is not a force in the way you imagine? Newton's picture, mass attracting mass, is useful but incomplete. Einstein changed everything. Mass and energy warp space and time. The planets don't orbit the sun because it's pulling them. They follow paths along curves in space-time itself. Imagine a trampoline with a heavy ball in the center. Place a smaller ball on the edge, and it rolls toward the center. There's no invisible string pulling it. It's the curvature of the fabric guiding the motion. That is gravity. Space and time themselves are malleable. They stretch, curve, and bend in response to matter and energy. Your gut tells you space is fixed, time ticks evenly, but both are flexible, dynamic, and interconnected. Now consider motion. You might feel stationary sitting in a chair looking around the room, but in reality you are hurtling through space at unimaginable speeds. The Earth rotates at about 1,600 kilometers per hour at the equator. It orbits the Sun at roughly 108,000 kilometers per hour. The solar system moves around the center of the Milky Way at nearly 828,000 kilometers per hour. And the galaxy itself is moving through the universe at over 2 million kilometers per hour relative to the cosmic microwave background. Stationary is a matter of perspective. Your brain tells you you are sitting still, but the universe sees you as racing through a cosmic ocean. Even time, the one thing you think you understand, is an illusion. We've discussed this before, but let's go deeper. Time doesn't flow. There's no universal now. The tick of your watch is not some absolute pulse of the cosmos. Time is a measure of change. If nothing changed, time would not exist. A photon of light experiences no time at all. It is born and absorbed in a single instant from its own perspective. And according to relativity, your motion through space affects your motion through time. If you travel close to the speed of light, your clock slows down relative to someone at rest. You age slower. Time is flexible, intertwined with space, not a rigid river flowing past you. And then there is the universe itself. Its scale is beyond imagination. You think of light years as enormous distances, but they are only the beginning. The observable universe is about 93 billion light years across, yet it might be infinite. Entire regions of reality are forever beyond our reach, not because of a lack of curiosity, but because the universe is expanding faster than light can travel through space. The cosmic horizon limits what we can ever know. There are places whose light will never reach us. The universe is much larger than our experience, and it will remain so no matter how advanced our technology becomes. Let's talk about matter. You might think your body, this chair, this room, the earth itself is solid. That solidity is an illusion. Atoms are mostly empty space. Electrons orbiting nuclei create electric fields that repel other atoms, giving you the sensation of solidity. Touching a wall doesn't compress some hard stuff. It's the electromagnetic interaction between your atoms and the atoms in the wall. The universe is not solid. It is mostly empty space, structured by forces and fields that we can barely see, but that govern everything we touch, feel, and interact with. And then there is the mind-bending reality of quantum mechanics. At the smallest scales, particles don't have definite positions until we measure them. They exist in superpositions, probabilities, clouds of potential. The universe is fundamentally uncertain at its core. Certainty, determinism, predictability, these are illusions that emerge only at large scales. At the level of electrons, photons, quarks, reality is a game of chance, a dance of probabilities. Yet out of that uncertainty emerges order, complexity, galaxies, stars, and life itself. The universe is not deterministic. It is statistical, probabilistic, wonderfully strange. So step back and look at all this. The stars are ancient, space is alive, gravity is geometry, time is flexible, matter is mostly nothing, and at the quantum level, reality is uncertain. The universe is not the simple stage your senses describe. Your intuition is a poor guide here. The universe is weirder, more elegant, more intricate than you think. And that, my friend, is just the beginning. In the next chapter, we will explore how the universe organizes itself, why patterns emerge out of chaos, and how life, consciousness, and complexity fit into this strange cosmic puzzle. You will see that the universe, bizarre as it is, has rules we are only beginning to understand, and they are far more beautiful than the myths your brain invents to make sense of reality.
If the universe were completely random, utterly chaotic, nothing would exist. Stars wouldn't form, galaxies wouldn't spin, life wouldn't arise. Yet here you are, sitting in a chair, reading this, in a universe that somehow managed to organize itself. How does that happen? How does chaos give rise to order? This is where things get truly fascinating. Start small. Consider a gas in a box. At first, molecules are moving in every possible direction, colliding randomly. You might think they'd never form patterns, but here's the trick. Even in randomness, statistical regularities emerge. There are more ways for particles to spread evenly than to clump together, so naturally, over time, they disperse uniformly. Entropy, the measure of disorder, increases. It's not a law imposed from the outside, it's just the way probabilities work. Out of randomness, patterns emerge. This is the fundamental arrow of time. The universe tends toward more probable states, and from that tendency, structures appear. Now scale up. Stars and galaxies didn't form by magic. They emerged because of gravity.
Gravity amplifies tiny differences in density. A slightly denser region of gas pulls in more matter, becomes denser still, and eventually collapses into a star. Repeat that process billions of times, and galaxies, clusters, cosmic webs appear. The large-scale structure of the universe is not a plan. It is the inevitable consequence of physics acting over billions of years on tiny initial variations. Chaos generates order, but the order is statistical, not deterministic. But this pattern-making doesn't stop at the cosmic scale. Look at life. You, me, every organism on Earth are patterns in the flow of energy and matter. DNA is a code that specifies a structure. Cells are self-organizing systems. Evolution is a process that takes random mutations, chaos, and filters them through natural selection, creating order over time. The rules of physics don't explicitly tell a bird to have wings or a tree to grow leaves, but given matter, energy, and environmental constraints, the pattern of life emerges. Complexity is not imposed, it arises naturally from interaction. And here's the kicker. The same principles of pattern and emergence apply to consciousness. Your thoughts, your awareness, the you reading these words, these are patterns of neurons firing in specific sequences. Electrical signals in your brain organize themselves in such a way that perception, memory, and reasoning appear. The brain is a self-organizing system, and your sense of continuity, of time, of self, is an emergent property. The patterns we recognize in the universe, from galaxies to living beings to consciousness itself, follow the same laws. They emerge from the interplay of simple rules and countless interactions over time. Let's pause and think about scale again. In the microscopic world, quantum mechanics rules. Particles appear and disappear, probabilities govern outcomes, and uncertainty reigns. At the human scale, we see order. Objects have defined shapes, predictable motion, causal chains. At the cosmic scale, stars, galaxies, and clusters exhibit regularity in patterns and structure. The universe is like a fractal. Complexity and order emerge from underlying randomness, and each layer builds upon the previous one. No level is separate. The small scales dictate the possibilities at large scales. Here's a fascinating experiment. Take a drop of water, a few grains of sand, or even a cloud of gas. Shake them, stir them, let them interact, and patterns spontaneously appear. Vortices, spirals, waves, dunes. These are not programmed. The particles are not intelligent. They follow local rules: motion, collision, conservation of energy. Yet the emergent pattern is undeniable. Nature has a built-in ability to organize itself, to create structure from chaos. The universe is not random noise. It is noise plus rules, and the rules give rise to predictability. Even light behaves this way. Photons traveling through space interfere, creating patterns of constructive and destructive interference. The double-slit experiment demonstrates this beautifully. Light seems particle-like, wave-like, even probabilistic. Yet when you observe the pattern over time, order emerges. Interference fringes, a predictable distribution. Patterns arise from the interplay of chaos and rules, from uncertainty and constraints. And the same goes for matter. Crystals, for instance, are nothing more than atoms following simple energy-minimizing rules. Each atom chooses the lowest energy position relative to its neighbors. Over time, an ordered lattice emerges. No master architect, no external force dictating the design, just physics and local interactions. The universe is a giant self-organizing system. Chaos is not the enemy of order. It is the seed from which order grows. Let's talk about complexity. Complexity is more than just order. A crystal is ordered, but it's simple. Life, the brain, ecosystems, they are complex. Complexity arises when you have multiple interacting parts with feedback loops. A single neuron is simple. 10 neurons are slightly more interesting. A billion neurons firing, communicating, adapting, learning, suddenly consciousness emerges. Complexity is a natural consequence of self-organization combined with variation and interaction. The universe has a remarkable tendency to produce it. So the next time you look at the night sky, remember, the stars, galaxies, planets, even you are patterns that emerged from chaos. You are a temporary alignment of matter and energy in an ever-shifting sea of probability. The universe is not a static stage or a rigid machine. It is a dynamic, self-organizing system, full of patterns emerging from the interplay of rules, chance, and time. And those patterns are not random. They are constrained by the laws of physics, guided by probabilities, and shaped by interaction. By understanding these patterns, by seeing the universe as a process rather than a collection of objects, you start to glimpse its beauty. You see why life can arise, why consciousness can exist, why the cosmos can form structures that span billions of light years. The universe is a magnificent tapestry woven from threads of chaos, probability, and rules, and you, in your fleeting moment of existence, are a part of that tapestry. In the next chapter, we will take this further. We will explore the deep laws of physics that govern these patterns, the mysterious constants of the universe, and the mind-bending consequences of the universe's rules, from black holes to quantum uncertainty to the ultimate fate of everything. You will see that even as the universe organizes itself, it hides secrets that challenge every intuition you've ever had.
Now that we've seen how the universe organizes itself and how patterns emerge from chaos, it's time to ask the deeper question. Why these patterns? Why this order? There's a reason the cosmos behaves the way it does. Hidden within the vastness of space and the minuteness of particles are laws and constants, immutable rules that shape everything. Without them, nothing would make sense. Let's start with something simple but fundamental, the laws of motion. Newton gave us a framework that works beautifully at the scale of everyday life. Push something, it accelerates. Gravity pulls. Energy is conserved. These laws explain apples falling, planets orbiting, and rockets launching. Yet Newton's laws are only an approximation. When you probe extremes, near light speed, near massive objects, or at quantum scales, they break down. Enter Einstein. His theory of relativity replaced Newton's absolute space and time with a dynamic, interconnected space-time. Energy and mass curve space-time, and objects move along those curves. Time dilates, lengths contract, and simultaneity is relative. Suddenly, what you thought you knew about the universe at a gut level turns out to be a convenient illusion. Next, let's talk about fundamental constants, numbers that the universe seems to be built upon. The speed of light, Planck's constant, the gravitational constant, the charge of an electron. These values are fixed, uniform across the cosmos, and astonishingly precise. Change them even slightly, and the universe as we know it could not exist. Stars would not shine, chemistry would fail, life would be impossible. These constants are like the rules of a game. Change one, and the entire game collapses. They hint at a deep underlying structure, a kind of cosmic tuning that allows complexity, life, and consciousness to emerge. And then there's the quantum world. Here, the universe is both deterministic and probabilistic. Electrons don't have definite positions until measured. Photons act as particles and waves. Particles pop in and out of existence. The vacuum itself is alive with activity, a sea of uncertainty. Yet even in this apparent randomness, rules exist. The Schrödinger equation governs the evolution of quantum states. The Pauli exclusion principle dictates how electrons fill orbitals, and the conservation laws hold firm. Chaos at the smallest scales does not imply lawlessness. Order emerges from the very fabric of uncertainty. Now, let's take a leap to black holes, objects that push physics to their limits. A black hole is a region where matter has collapsed so densely that not even light can escape.
Its gravity warps space-time to the extreme. Time slows near it. Tidal forces stretch objects, and the very notion of space becomes distorted. And at the center lies the singularity, a place where density becomes infinite and the known laws of physics break down. Black holes teach us something profound. The universe has edges where our understanding falters. They are not just exotic phenomena, they are windows into the fundamental structure of reality. But there's more. The laws of thermodynamics govern the flow of energy and the arrow of time. Entropy, disorder, always increases in a closed system. Stars burn, life evolves, galaxies collide, all in accordance with this principle. Entropy explains why we remember the past and not the future. It explains why eggs break and don't reassemble themselves. The universe's tendency toward disorder is what gives time its apparent direction and what allows complex structures to emerge temporarily, even as chaos spreads. And now, the ultimate question, the fate of the universe. Is it infinite? Will it collapse? Will it drift into heat death, a state of maximum entropy where nothing interesting can happen? Observations tell us the universe is expanding at an accelerating rate. Galaxies are moving away from each other faster over time, driven by dark energy, a mysterious force we barely understand. If this continues, the universe may end in a cold, empty expanse, stars burning out, matter decaying, photons fading into silence. It's a sobering vision, but it is the logical consequence of the rules we observe. Yet, even in this vast, impersonal system, the universe remains astonishingly ordered and elegant. From the quantum foam to black holes, to the cosmic web of galaxies, there is a unity in the rules. The same laws that dictate the paths of planets also dictate the behavior of electrons and the formation of stars. The universe is not random noise. It is a coherent, rule-governed system where patterns arise naturally, complexity emerges from interaction, and life can appear, briefly, to observe it all. And that brings us to something remarkable. You, reading these words, are part of the universe observing itself. The atoms in your body were forged in stars. The same physics that governs distant galaxies governs your neurons. The patterns of matter and energy in your brain allow you to contemplate quantum uncertainty, black holes, and the ultimate fate of everything. Consciousness is an emergent property of the cosmos, a fleeting alignment of matter and energy that allows the universe to reflect on itself. You are a witness to the laws you cannot alter, the constants you cannot change, and the patterns that will persist long after you are gone. So, let's summarize what we've learned across these 3 chapters. The universe is not what it seems. Space and time are malleable. Chaos and probability give rise to order. Fundamental constants and laws shape the cosmos. Black holes and quantum uncertainty challenge our intuition. Entropy dictates the arrow of time, and yet life and consciousness emerge as temporary patterns of incredible complexity. The universe is elegant, strange, and infinitely fascinating, and we are its observers. This is the Feynman way of seeing the universe, not as a static stage, not as a simple machine, but as a dynamic, self-organizing, rule-governed, astonishingly beautiful system. Every particle, every photon, every human thought is part of that grand cosmic dance, and understanding it, even in small pieces, is the most profound adventure imaginable. So now you know, the universe isn't what it looks like. Space, time, matter, and energy are far stranger than our senses can imagine. Yet, understanding even a fraction of this cosmic dance changes how you see everything, from the stars above to the life around you to the very thoughts in your mind. If this journey through the universe opened your mind, don't stop here. Explore further. Watch, read, question, and never stop asking why. The universe rewards curiosity. Every pattern, every law, every particle has a story to tell, and the adventure of discovering it is endless. So hit like if you're ready to see the universe in a new light. Subscribe if you want to travel deeper into physics, reality, and the mind-bending truths that Feynman loved to share. And comment below, what blew your mind the most today? Your curiosity fuels this journey, and together we'll keep uncovering the universe, one chapter at a time. Remember, the universe is stranger, more beautiful, and more interconnected than you think, and you are part of that story. Stay curious, stay amazed, and keep looking up.